Hello and welcome to this session of past CSEC multiple choice questions. In this segment, we'll be trying to work around some concepts that were measured from the CSEC syllabus and is being placed into the multiple choice segments or sections. Do enjoy. I'm Hiro Baljo. This question reads, if x and y are two finite sets such that the number in x is equal to 7, the number in y equal 5, and the number in x intersect y equal 3, then the number in x union y is? Now, here we have a question that is asking of us to find the number in x union y, which is the universal set, given the number in x in set x equals 7, the number in set y equals 5, and the intersection of the two of them is 3. Now, when we look at this set here, we could have seen the number in x, the total number in x is 7. However, a part of x is equivalent to 3, hence the remaining piece would have been 7 minus 3, which would have given us 4. Likewise, the number in y is equal to 5. However, piece of y, which is also in x, is equal to 3. Hence, this remaining part here would have been 5 minus 3, which would have given us 2. Therefore, the number in x union y would have equal to these regions here when we sum them, and that would have been 4 plus 3 plus 2, which would have given us 9. So the solution for this question is B, 9. A plane is flying in a direction of 0.45 degree and changes course in a clockwise direction to 135 degree. The angle through which the plane turns is. So here's where we have a reference point of the true north. This plane is traveling on an angle of 0.45 degree to some direction, after which this plane changes its course in a clockwise direction to 135 degree. They're asking us at what angle did this plane turns, and we're looking for that angle there. Now, using the concept of straight angles, we would have seen this angle here, angle theta, comprises, or we can find it by the compound angle of 135 from 180 should have been the straight line from north to south. So this angle here would have been 180 minus 135, which would have given us 45 degree. This angle here, this complement of the angle here, would have been, if we were to use the concept of alternate angles or z angles, therefore is the size of this angle would have been the size of this angle. Therefore, Q2 plus Q1, which would have been those two complement angle, would have been Q equal to Q. We know that Q2 would have been 45 degree Q1 is 45 degree. Hence, the angle Q would have been 90 degrees. So this plane rotated at an angle of 90 degrees. B would have been our solution for this question. This question reads, and it involves laws of indices. If we have a fractional quantity 2 upon 3 raised to the second power, what is this equivalent to? Now this would have been equal to the same as 2 square upon 3 square, squaring each quantities. Now 2 square would have been the same as 2 times 2, and 3 square would have been 3 times 3. In computing this, we would have had 2 by 2 give us 4 upon 9. So our solution for this question is D, 4 upon 9. The value of the digit 5 in the number 537 is, here we have a question that is asking us for place value in a number 537. Now if we were to divide this number into the different components, we would have seen that 7 is in the unit column, 3 is in the tens column, and 5 would have been in the 100 column. They're asking us for what is the value of 5 in this number. The value of 5 would have been 500. So our solution for this question is C. In the diagram, AB and CD are parallel. Which of the following best describes the relationship between X and Y? Here we have a parallel line cut by a transversal, and they're asking us to make a comparison between angle X and angle Y. Angle X and angle Y, if we were to look at them using the concept of Z angles, we know that Z angles are alternate angles, and alternate angles are equal angles. Hence, the relationship between X and Y is that X is equal to Y. So our solution is A. At the end of any year, a car is worth 5% less than what it was worth at the beginning of the year. If a car is worth $10,000 in January 2011, then its value in December 2011 would have been. Now, they gave us the value of this car at the beginning of the year. So, as of January 2011, the value of this car was $10,000. But they tell us that within the year, this car loses a value. So this car depreciates at 5% of value. Hence, this car would have worth at the end of the year. So at the end of the year, December 2011, this car would have had a value of 95%. That is, the value at the starting of the year minus the depreciated value of 5%. Hence, they're asking us what would have been the value of the car. So, what we need to do is to find 95% of the value. And 95% of the value of the car would have been $9,500 at the end of December 2011. So the solution for our question would have been B. If 5 of 2x minus 1 equals to 35, then the value of x would have been what? Here we have a linear equation and we are asked to solve for x. Now in solving for x, there are some concepts we need to apply, and those concepts are: first, removal of the bracket, and we're going to remove the bracket by the coefficient of the bracket. So this would have given us 5 of this value plus, and why we get plus? We get plus because the value of this 5 here is positive. So that's how we get this plus sign. Plus 5 of minus 1 should equal to 35. That's our first step in solving this equation. So we need to simplify first before we solve. What would have been 5 of 2x? This would have given us 10x. 5 of minus 1 would have been minus 5, should equal to 35. In balancing our equation, we would have had 10x minus 5x. 10x minus 5 plus 5 should equal to 35 plus 5. And further simplifying, this would have given us 10x should equal to 40. A negative 5 go out with a positive 5. In further balancing our equation, for 1x, we would have had 10x divided by 10, 40 divided by 10. X would have equal to 4. So the solution for this question is D, 4. 3x squared times 2x cubed equals. In this question, we have two algebraic quantities multiplying by each other. Here we'd have to apply laws of indices to show the multiplication of the algebraic terms. However, we have coefficients of these variables. So what we do, we take the 3 and the 2, the coefficients of those algebraic terms, multiply them. And what happens to the algebraic term is that when we are multiplying base quantities which are the same, applying the laws of indices, what happens to the power is that we add the power. So this would have given us 6 of x to the 5th power. The solution for this question is A, 6x plus 5. This is a direct substitution question, and it reads, if x equals 4 and y equals 2, what is the value of x squared plus 3y divided by xy? Now they're asking us, given x is a value of 4 and y is a value of 2, what would have been x squared plus 3y divided by xy? So what we need to do is to substitute where x is the value of 4 and where y is the value of 2 and compute. So in substitution there, we would have had x squared would have been the value of 4 squared, 3y would have been 3 of 2, and xy would have been 4 times 2. In substituting these values into this expression here, we would have had 4 squared plus 3 of 2 divided by 4 times 2. in computing this, we would have had 4 square would have been 4 times 4. So this would have given us 16 plus 3 times 2 would have given us 6. 4 times 2 gave us 8. In further simplifying, 16 plus 6 gave us 22 divided by 8. In simplifying 22 upon 8, this would have given us, if we divide throughout by 2, 2 into 8, 4, 2 into 22, 11. 11 upon 4 written as a fractional term gives us 2 and 3 upon 4. So the solution is D, 2 and 3 upon 4. The sum of two positive numbers, P and Q, is 32. Their difference is 12. What is the smaller number? So here we have a question which reads that we have two numbers, P and Q. When we add them, they give us a sum of 32. When we take these same two numbers and find their difference, it is equivalent to 12. They're asking us which of this number, they're asking us which of these two numbers is the smaller one, P or Q. What we need to do here is to find the values of P and Q and compare which is larger or which is smaller. This question they're asking us for which is smaller. Now here we have two equations and we can solve them simultaneously. When we look at the two equations here, if we add these two equations, a positive P go out with a negative P, what remains is these values here. If we were to add them, we would have had 2P gives us 44. In balancing this equation, 2P, where the value of 1P would have been 22, 2 ones, 2 ones, 2 ones, 222. In substituting the value of P to find the value of Q to make that comparison, we could see that if P plus Q is equal to 32, and we know the value of P is 22, by substitution, we would have had 22 plus Q equals to 32. In balancing our equation, we would have had 22 minus 22 plus Q should equal to 32 minus 22. Whatever we do on one side of the equation, we should do on the other side to keep the balance of our equation. Hence, the value of Q would have been 22 go out with 22. 32 minus 22 gave us 10. So when we look at these two values, we have P is equal to 22 and Q is equal to 10. Hence, the smaller of the value would have been Q, which is 10. So our solution is A. 7 times the product of two numbers, A and B, may be written as. Now, when we read this question, they're telling us 7 times the product of two numbers. Product means multiply. So if we were to write this here, it's equivalent to 7 of A, B. So our solution would have been A, 7 of A, B. This question reads 2 of A squared B raised to the third power is equal to what? Now, in applying laws of indices, they tell us that one of the laws states that when we have an external power of quantities raised to power, what we do with them is we apply the multiplication rule. So what we're saying here for this question is by applying the laws of indices, this would have been 2 of a square times the power that it is raised externally by. And b has a power of 1. So this here is equivalent to this in its expanded form. In simplifying, what is 2 of a raised to the second power times 3, b raised to the 1 power times 3, this would have given us 2 of a to the 6 b cubed. So our solution for this question is B. For all a and b, and here they give us algebraic terms, and they're asking us for all a and b here, what would have been when we simplify these algebraic terms here, what this would have equaled to. Now, for all a's and b's, we'll have to go and apply the rule of removal of brackets. And how do we remove brackets? Whatever is the coefficient of the bracket, we multiply each term inside of the bracket by. Whatever is the coefficient of the term, we multiply each term in the bracket by. So if we were to apply that rule, we would have had 3a times a plus, and again this plus come because the coefficient of this 3a, it's positive, so that is where we get this plus sign from, plus 3a times 2b minus b, that's our second bracket now, minus b times 2a minus b times minus 3b. Now this minus comes from this quantity. In simplifying, we would have had 3a times a give us 3a squared, multiplying the quantities. When the base quantities are the same, we add the power, applying the laws of indices, plus 3a times 2ab give us 6ab, minus b times 2a give us minus 2ab, and minus b times minus 3b give us a positive 3b squared, multiplying algebraic terms, a negative by a negative gives us a positive, the power raised to 1. For the simplifying, 3a squared, when we look through these terms, there's no other a squared term, so we could leave that alone. However, we would have seen here we have a positive 6ab and a minus 2ab. In simplifying, 6ab minus 2ab would have given us a positive 4ab, and there's no other b squared term, hence we rewrite the 3b squared. So our solution for this question for all a's and b's would have been 3a squared plus 4ab plus 3b squared, which would have given us B, the solution for this question. If P, and they give us the matrix P with these values 8, 6, 7, 5, they're asking us to find the determinant of P, which is the modulus of P. Now, the determinant of a matrix is found by the leading diagonal members, the product of the leading diagonal members, less the product of the non-leading diagonal members. How do we know the leading diagonal members? The leading diagonal members are those members leaning from left to right diagonally. So that's leading. The non-leading would have been from right to left diagonally. So this here is non-leading. Now, to find the determinant, the determinant would have found by the product. So the modulus of P would have found by 8 of 5 less 6 of 7. So the modulus or the determinant of the matrix P would have been 8 by 5 would have been 40 minus 6 by 7 would have been 42. So the determinant of this matrix would have been minus 2. The solution would have been B. When 8 is subtracted from a certain number and the result is multiplied by 3, the answer is 21. What is the original number? Now here we have a question written in worded form. We need to interpret it mathematically and solve to find that missing number or the original number. Here's what they said. If we have a number, let us call this number n, and when we subtract 8 from this number, and the result we multiplied by 3, this answer here is equal to 21. What is this original number? Now here we have a linear equation and we can solve for that number removing the brackets. It's our first concept. So this would have been 3 times n plus, and where we get this plus from, it's because this value is positive here. So that's where this plus sign comes in from. Plus 3 times minus 8 should equal to 21. In further simplifying, 3 times n would have been 3n. Positive 3 by negative 8 give us minus 24 equals to 21. In balancing this equation, 3n minus 24 plus 24 should equal to 21 plus 24. In simplifying, 3n would have equaled to 45, where this number n, in further balancing our equation, should equal to 45, where n would have equal to 15. So the solution for our question is D, 15. If the vectors P and Q are 3, 2 and minus 1, 4 respectively, then P minus 2Q is. So here we have this question involving a vector concept telling us that the vector P is 3, 2 and the vector Q is minus 1, 4. They're asking us what would have been P minus 2Q. In substituting for P and Q, we would have seen P, which is 3, 2. We need to subtract 2 of Q. 2 of Q would have been minus 1, 4. Now this is a scalar multiplication of vector Q. So in further simplifying, this would have been 3, 2 minus the scalar multiplication would have been minus 2, 8. That is 2 of 1, 2 of 4. In further computing, these two vectors to show the result of P minus 2Q, this would have equal to 3 minus minus 2 and 2 minus 8. In computation here, P minus 2Q would have been 3 minus minus 2 would have given us a positive 5. 2 minus 8 would have given us minus 6. Therefore, the solution for this question is 5 minus 6, which is 8. The item refers to the following parallelogram WXYZ. In the parallelogram, R is the midpoint of XY. So here we have a parallelogram, and the parallelogram, the two opposite sides are parallel and equal. So in a parallelogram, X, Y, R is the midpoint. So R should be somewhere here. R, midpoint, that's halfway between X and Y. We have WZ. They're asking us, based on the information above, vector ZR, vector ZR would have been what? We're looking for this vector here, vector ZR. It's moving from Z to R. They're asking us what would have been that vector there. Now, when we look at this question, they didn't tell us what are lengths, so we need to make a comparison as to see what would have been this vector here. Now, here we have this parallelogram, and they're asking us for ZR. For us to find vector ZR, we need to apply the triangular law of vectors. The vector is moving from R to Y, Y to Z. We need to find vector RZ. Now they tell us that this vector is moving from Z to R. We know that it is coming from Y or X or R to Y. And if it's moving from Z to R, therefore we have this vector is moving from Z to Y. Applying the triangular law of vector, we would have seen the two sides that are going in the same direction, which would have been ZR, plus vector RY would have given us the size of this vector here, which would have been ZY. Now, if we were to look at what is the value of Ry, Ry would have been half of vector xy. So in substituting these values here, we could see that ZR plus half of vector xy, which would have been the same as Ry, is equal to vector zy. In finding for ZR, that is vector ZR, would have been equal to vector ZY minus half of vector XY. However, when we look at the solution there, no vector was written in terms of XY. It was given in terms of ZY and X. Now here's where we need to make the comparison to show that ZY is equal to WX. ZY, that is vector ZY, is equal to vector WX, because it's a parallelogram. So in substituting for that there, we would have seen ZR, vector ZR, would have equal to vector WX, which is this deduction here to show that ZY is equal to WX in a parallelogram, minus half of XY. And here we would have seen again that vector XY is equal to vector W Z. So if we were to find half of xy, this would have equal to half of vector wz as well. So in substituting half of wz, the solution for our question here to find vector zr, it would have been vector zr is equal to vector w x minus half of vector w z. So the solution for this question is A. 600 students write an examination. The probability of a random selected student failing the exam is 1/5. How many students are expected to pass? Now, we have a question that tells us here that 600 students wrote an exam, and out of this 600 students, 1/5 is expected to fail. Now, if 1/5 is expected to fail, therefore 4/5 is expected to pass. Therefore, the question is asking us for what number of students are expected to pass. So if you were to find 4/5 of the total, which would have been 600, we would have had 480 students are expected to pass this exam. So our solution for this question is B. This question tells us that two fishermen caught 20 fish and their length were measured and put onto a frequency polygon. They're asking us for the interquartile range. The interquartile range is found by when we divide the cumulative frequency into quartiles and bring these values and read them off from the horizontal plane. Now our interquartile range would have been found by taking the Q3 value and we less the Q1 value. That would have given us the interquartile range. So if we were to put values attached to these quartiles, we would have seen if we have 20 fishes, the first quartile would have been at 5, the second quartile would have been at 10, the third quartile would have been at 15, the fourth quartile would have been at 20. However, we're interested in the first quartile value. The first quartile value at 5, when we meet that cumulative curve, when we were to bring these quartile values at 5, meeting the curve and bring down to read this point, our Q1 value from the graph would have been 1.2. Our Q3 value from 15, we come to the curve and we bring down that value, we read off this value here at Q3. This would have given us a value of 3.7. Now, in substituting in the formula Q3 minus Q1 to find our interquartile range, we would have seen that if we substitute these values, 3.7 minus 1.2, which would have been the IQR, interquartile range, our IQR would have equaled to 2.5. Hence, the solution for this question is C. Here we have a question based on binary operation, and it reads, if A operation B is equal to A upon B minus 1, then what would have been 7 operation 28? A operation B give us A upon B minus 1. They're asking us they're asking us what would have been 7 operation 28. Here's where we're substituting for A and B respectively the values of 7 and 28 in this equation here and simplifying. Hence, if A is 7, this would have been 7 upon 28 minus 1. In simplifying, 7 ones, 7 fours. In further simplifying, 1 upon 4 minus 1 upon 1. It's the same as solving a fractional quantities. 4 into 4, the LCM of 1 and 4 would have been 4. 4 into 4, 1. 1 times 1 would have given us 1. 1 into 4, 4. 4 times 1 give us 4. What is 1 minus 4? It's minus 3 upon 4. Hence, the solution for this question is A, minus 3 upon 4.